Good afternoon, everyone. Myself, Samarthita Sasmal, and today my topic is understanding the Chinese remainder theorem. And today I will be discussing about the key concepts and its real-world applications in cryptography, basically in domain of number theory. Let's move to the topic. And today I will be covering about the overview and what theorem says, about the theorem statement, and we will be discussing about few example of it and the applications and the few references. You guys will follow the books regarding that. So now, talking about Chinese remainder theorem, basically it is a tool. Basically, it is a theorem, and it is using as a tool for solving system of congruences. Now you may ask that what is congruences? Basically, a system of congruences is a collection of congruence equations that need to be satisfied simultaneously. Means congruences are the part of a modular arithmetic and involve conditions where two numbers have the same remainder when divided by a given modulus. Means the given number should be co-prime. Okay, so means the remainder will be the same. And the Chinese remainder theorem statement says, suppose n1, n2 and up to nk are pairwise co-prime positive integers, means their GCD will be 1. Okay, and then the system of congruences that just I have discussed right now, that is the x congruent to a1 mod a1, and this will be continuing up to x congruent to ak mod nk. Okay, n times n number of system of congruences. And Chinese remainder theorem says that these congruent equations has a unique solution modulo, that we can say like capital N, and capital N will be the product of N1, N2 and up to Nk. Okay, everything I will be discussing, don't panic. Okay, so now the value of capital X, that is a random variable, and the value of X can be, this is X equals to summation I equals to 1 to K AI capital Ni Yi mod N. Okay, so now capital Ni equals to capital N by small ni, and Yi is the modular multiplicative inverse of capital Mi modulo Ni. So the problem and the doubt will be cleared when I will be discussing by taking a real world example, right? So now the CRT means the Chinese remainder theorem is used to solve a set of different congruent equations with one variable but different moduli. Like see, here the moduli is n1, the n2. For n different equations, there are n different moduli. Okay, and they should be relatively prime. This is the most important characteristics for the Chinese remainder theorem. Okay, and this is shown like below. These are the equations, and that I have mentioned now, that one fixed variable, and that fixed variable is here x. And CRT means Chinese remainder theorem states that the above equations, means these equations have a unique solution moduli and that are relatively prime. Okay, and this is the mathematical representation. Let's move forward to the example. See, solve the following equations using CRT. This is like that x congruent to 2 mod 3, x congruent to 3 mod 5 and x congruent to 2 mod 7. Here we have to calculate, means our motto is to calculate the value of x using the Chinese remainder theorem. Okay, so there are few solution steps, like step 1, verify pairwise co-primality moduli 3, 5, 7. Here see 3, 5, 7. If we will be checking if they are co-prime, let's see, the GCD of 3, 5 and 7 is 1, means the 1 is the one and only common factor. Okay, means they are co-prime. This is the first step, the first verification step, that these equations will satisfy the Chinese remainder theorem. Okay, let's move forward to the next step. that is compute the product of capital N, and that should be N1, N2 and N3. Like if we can compare with the standard equation, that was, let's see, like this, mod N1, mod N2, mod Nk, and if we compare, like these are the N1, N2, N3 value, and capital N equals to like the product of N1, N2 and N3. Here three constants, so that's why N1, N2, N3. If there are more than 3, then the formula will be changed according to that. Okay. So next we will be solving the value of x. Okay. Let's see. And first we will be comparing with the standard expression, and we have a1 equals to 2, a2 equals to 3 and a3 equals to 2, and a1 equals to this, and we have already calculated the value of a. Okay. And then we will be computing the partial products, that is capital N1, capital N2 and N3. Let's see the previous slide. Here the Ni equals to capital N by small ni. Okay. Now see, just we have calculated this. Capital N1 equals to capital N by 3, that is Ni, means this is N1, for the I value is 1, 2, 3, that is N1, N2, N3, and similarly just we will be getting the value like capital N by 3, that is 35, N by 5 equals to 21, and the final is N by 7, means 105 by 7, that is 15. Okay. And next step is we will be finding the modular inverses, that is yi. We have declared the value yi. Here also the three values, means I equals to 1, 2, 3, y1, y2 and y3. And see the first how we will be calculating the value of y1, means y1 into capital N1, that is congruent to 1 mod N1. Okay. And y1 into N1, that is 1 mod 3. The value of N1 equals to 3. Okay. So now here the calculation or the getting value of y1, that is little bit tricky. So now let's start. Okay. The y1 into 35. Okay. The N1 value is 35. See. Okay. So to calculate y1, we will be trying like the trial and error method. Means we will be putting the value of y1, 1, 2, 3. We will be just going forward like that way. Okay. And we will be stopped when the remainder will be 1. Okay. We will be stopped when only the remainder will be 1. Means see, when we will be putting the value of y1 equals to 1, that means 1 into 35 congruent to 1 mod 3. Means when we will be dividing the value 35 by 3, we will be getting the remainder as 2. Means the condition is not satisfied. So move forward to the value y1 equals to 2, means 35 into 2 means 70. And when we will be dividing the value 70 by 30, we will be getting the remainder as 1. Okay. And that is why the y1 equals to 2. And we will be trying similarly for y2 and y3, and we will be getting 1 and 1 respectively. Okay. And now we have all the formula for all the required values to get x. Okay. Now we will be just simply putting all the values in the x. And what was the required formula? Like x equals to summation I equals to 1 to k, ai, ni, capital Ni, small yi, and mod capital N. And summation means I equals to 1 to k, and here I equals to 3, means we will be starting from I equals to 1 to 3, means a1, capital N1, y1. See, here I have mentioned a1, capital N1, small y1, and up to a3, n3, y3, mod N. So just put the values, respective values, and after calculation we will get 233 mod 105. And when we will be dividing 233 by 105, we will be getting the value of x as 23. And now move forward to the application portion. We will be trying with another kind of example. Just a minute. I need a blank page to solve the questions. Just a minute, and I'm sharing a new screen to solve the new example. Okay. Okay. My new screen is now clearly visible. Okay. Let's move to the second example. Right. So, second example actually looks like 4x congruent to 5 mod 9 and 2x congruent to 6 mod 20. Okay, see, this equation is not looking as our standard equation, right? Because in our standard equation there is no coefficient of x, but here in the first equation here the coefficient of x is 4, and for the second equation the coefficient of x is 2. So now we have to remove these 4 and 2, and we have to rearrange these equations by as our standard equation, right? So now to rationalize or to vanish the coefficients, we have to do, right? Suppose I am marking this is like 1 and 2. Now multiplying 1 by 4 inverse. Now see, if we multiply 4 into 4 inverse means this we will get 1, right? 4 inverse means 1 by 4. 4 into 1 by 4. Okay. On both sides. So 4 inverse into 4x congruent to 4 inverse into 5 more, right? So now x congruent to 4 inverse cross 5 mod 9. And again now we have to remove the 4 inverse, right? So now we will get 7. I don't want to do any kind of step jump so that you can understand so much better. So 4 inverse mod 9 and into 5 mod 9. So or x congruent to 7 into 5 mod 9. So 4 inverse mod 9. Okay. So we will get 7. Remainder as 7, or x congruent to 35 mod 9. So if we divide 35 by 9, then we will get the remainder. Means we will simplify this. Now we will be having the simplest form, right? So x congruent to 8 mod 9. Okay. So this is the refined form of equation 1. And similarly, for equation 2, 2x congruent to 6 mod 20. Now, to remove 2, we don't need to multiply another numeric value, right? If we represent 6 as the product of 2 different multiples, like 2 into 3 mod 20, I think now 2 will be vanished, right? So now we will have x congruent to 3 mod 20. Means this is the refined format of equation number 2, and this is the refined format of equation number 1. So now it looks like our standard equation, right? So now we have to solve this. Okay, this is our first steps. Just we need to arrange those equations, those given equation just to see exactly looks like our standard equation of Chinese remainder theorem, right? So now we have to solve these two, and if we compare like x congruent to a1 mod n1 and x congruent to a2 mod n2, here will be given like, and here also I am writing the required formula of finding x, like x equals to, as there is two equation, so a1 n1 y1 plus a2 n2 y2 mod caps n. Okay, so now if we compare these two, we'll be having given a1 equals to, see, a1 equals to 8, a2 equals to 3, n1 equals to 9, n2 equals to 20, right? See, 8, 3 and 9, 20. Okay, so these are the given values, and now we have to calculate capital N1, that is capital N by small n1. Here actually we don't calculate the value of capital N, right? Here capital N equals to N1 into N2, right? N1 into N2 means 9 into 20, that is 180. Okay, small n1 means 9 means 20, and capital N2 means n by n2, that is 180 by 20, that is 9. Okay, so now just we need to calculate the modular inverses. What was the modular inverses? Like y1 and y2 means yi. Here this is there are just two equations. For two equations there will be two modular inverses. For first equation that is y1, and for the second equation that is y2. So now we just need to calculate the value of y1 and y2 to find or to calculate the our required value of x. Okay, the fixed variable for the Chinese remainder theorem. So now y1 का वो फॉर्मूला क्या होता है? Now y1 into n1 congruent to 1 mod n1. Okay, so y1 into 20 congruent to 1 mod 9. Okay, so now what is the procedure? Means the total product divided by 9, and we will get the remainder as 1. Okay, when the remainder value will be 1, then we'll stop. Just I have discussed all the procedures and all the rules just in our previous example. Okay, this is like this example is quite looking different, so I think we should try this also. Okay, and so see, this is also a trial and error because we don't know the value of y1 like before. Okay, so we have to try the value by starting from 1. Okay, so try 1 into 20 and divide it by 9. So no, it is not coming 1. So I am proceeding, and let's try for 20 into 4. 20 into 4, again the remainder is not 1. So let's try for 5. Okay, so now or 20 into 5 congruent to 1 mod 9. See, the remainder is 1, because 20 into 5, 100, and when we will be dividing by 9, it will be 99 and remainder as 1. So our required value y1 equals to 5. Okay, and for y2, this is also n2 congruent to 1 mod n2, right? 1 mod n2. So now it is also, let's try for big integer. Okay, so try for 7, because y2 and n2 value 9 congruent to 1 mod 20. Why I have said to start with the big integer, because see, here we have to divide the value by 20. Okay, 20 is a big value, because when we will be dividing a value by a big integer like 20, so means the value we need to divide, that should be bigger than 20, right? Then we will get the remainder as 1. So now let's try from 7. So 7 into 9 and divided by 20, it is not 1 as remainder. So then 8. 8 into 9, then it is not remainder as 1. So let's try for 9 into 9. So 9 into 9, that is 81, and 81 divided by 20, 80, and right. Now the remainder is, so just okay, y2 means 9 into, or 9 into 9 congruent to 1 mod 20. Okay, so here y2 equals to 9, means our formula is, we will stop when we will get the remainder as 1. Okay, so all the value to calculate ax, I think all done. Okay, so just put these values on this equation, like this is number 3. Okay, this equation. So now x equals to, I'm not repeating by writing the formula again, just I put these values. Okay, so a1 means 8 into n1 means 20, y1 means 5, and a2 value 3 and 9, n1 and 9. Okay, and then mod capital N value 180. So 8 5 is a 40 into 2 20, that means 800, and 9 is 81 into 3 1 3 2 4, and then mod 180. Okay, and then 1043 mod 180. So when we will be dividing the value 1043 by 180, so we will get the value of x as 143. So this is our required value of x, right? This is the answer. Okay, I think it is clear to all of you. This is as example 2. Okay, I think this is a different kind of equation and I have solved it. Okay. So we will be forwarding our next section, that is application. Okay. Application of Chinese remainder theorem in terms of cryptography. Okay. Just I will touch simple things. Okay. Let's coming to our next slide. Okay. So this is our next slide. Okay. So because the Chinese remainder theorem is used to speed up the modular exponential and kind of decryption algorithm. Okay, so like RSA, and it is used to use significantly to improve the efficiency of the algorithm, right? So and CRT means Chinese remainder theorem also helps in distributing and reconstructing the large data across multiple servers or memory locations, okay, ensuring the reliability and the fault tolerance. Means it helps in the data storage, okay. And finally, the error detection, in terms of error detection and correction, it utilized in the coding theory to detect and correct the errors in transmitted data by working with remainders modulo different bases, okay. So that is the thing we just now visualize, that how the remainders is differentiating and how it is coming in different cases, and this is the crucial value that need to use in the cryptography in several sections. Okay, so Chinese remainder theorem is basically so much important in the cryptography, and you guys may follow the book of elementary number theory to study the cryptography portions as well as the Chinese remainder theorem. Okay, the for the number theory systems in cryptography, you guys may follow the book of Roshan. Okay, and there is also available so much papers in Google Scholar. Okay, there's so much resources you guys can follow. So this is up to you, and now thanks to all of you for listening my lecture today. Okay, thank you all. Bye.